So we are on Unit 7, Lesson 2. We're going to talk a little bit about trig ratios. So what we're going to be doing is we're going to be talking about the different type of trigonometric ratios in triangles. So first off, let's just look over here. It says identify the parts in the right triangle. So here we've got a right triangle. And this is where your right angle would go, okay? So C is your hypotenuse, A is a leg, and B is also a leg, okay? So we have three basic trig functions, and they are sine, cosine, and tangent. Now the sine, we have a saying for sine, cosine, and tangent, and that is called SOHCAHTOA. Now, what does that stand for? Well, let's go back to our notes. So our sine of A is the side opposite over the hypotenuse. So what does that look like? Well, if it says sine A, that means we're starting at angle A. And if we're talking about opposite over hypotenuse, we're going to talk about what is the side that's opposite A. So the side that's opposite A is side BC, and the hypotenuse of angle A is C. It's the side that is opposite of your right angle. Again, so SOH, sine of A, O, opposite, H, hypotenuse. Now we're going to talk a little bit about cosine. So cosine is adjacent over hypotenuse. Now what does adjacent mean? Adjacent means the leg that's next to. So if we're looking right here at angle A, the adjacent side would be side B. So TOA is TOA. So we're talking about tangent, opposite over adjacent. So if we're looking at angle A, the opposite side would be A over adjacent, and adjacent to angle A would be angle B, or side B. So we would have side A over side B. And last we have cosine. Now cosine is the adjacent side over our hypotenuse side. Again, we are starting at angle A. So if we're talking about the side that's adjacent to angle A, we're talking about side B. And if we talk about the side hypotenuse, it would be the angle that's opposite of the right angle, which is side C. So let's do our first problem. Example 1 says, use angle A, so we're going to start here, angle A, right here. And it says set up the following ratios. So we want to see what is the sine, the cosine, and the tangent. So let's go ahead, let's go to our work. So the best thing that you need to do is you need to memorize this saying, SOHCAHTOA. And the sine is, again, opposite over hypotenuse, which is OH, opposite over hypotenuse. Cosine is adjacent over hypotenuse, AH, adjacent over hypotenuse. And then TOA, or tangent, is opposite over adjacent, opposite over adjacent. So in our problem, it tells us to start and to use angle A. That means that for the entire problem, you're going to go ahead and use angle A. So I just went ahead and circled it so it's a little bit easier to see. Now, angle A, it says A is the side opposite of angle A. So we're going to go ahead, we're just going to label it. So side A is the side that's opposite of angle A. Side B is the side that is adjacent to angle A. And then obviously side C over here, side C, is going to be opposite of your hypotenuse. So side C is your hypotenuse. Now let's go down to our ratios. Sine A, so angle A, the sine is opposite over hypotenuse. So the side that's opposite of angle A is side A. So side A over the hypotenuse, our hypotenuse is side C, so A over C. Cosine is COA, so it's adjacent over hypotenuse. So again, we're still starting at angle A because it's cosine of angle A. And Cosine is adjacent over hypotenuse. So adjacent is the side that is next to the angle. So B over hypotenuse, which would be C. So B over C. And then finally we get tangent. Tangent is opposite over adjacent. We're still starting at angle A. And opposite, the side opposite of angle A is side A, and the adjacent side is right here. That is side B. So it's going to be A over B. All right. Now let's go ahead and we're going to put some numbers into this, okay? So example 1, what it gave us is it says use angle A, and we need to find what is the sine of angle A, what is the cosine of angle A, and what is the tangent of angle A. Now again, I went ahead and I drew out my triangle and I circled the angle that I'm going to use, and then I just went ahead and labeled my sides. So the side that is opposite of angle A is 3. The side that's adjacent to angle A, or right next to, is side 4. And then our hypotenuse is the side opposite of my right angle, which is 5. So my sine, if I go back up to SOHCAHTOA, my sine is opposite over hypotenuse. So we're still looking at angle A. So opposite over the hypotenuse would be 3 over 5. Opposite over hypotenuse. And then we're looking at the cosine of A. So the cosine is COA, is CA. So it's adjacent over hypotenuse. We're still using angle A. So adjacent would be side 4 over our hypotenuse, which is side 5. So you're just going to have the cosine of A is 4 over 5. And then last, our tangent. Our tangent is TOA, which is opposite over adjacent. We're still using angle A. Opposite is 3, and our adjacent is 4. So you're going to have tangent A is 3 over 4. Okay, so let's go ahead and let's go down to example 3. Example 3, again, we're finding the sine, the cosine, and the tangent. Now we're going to do it with 2 angles. We're going to find all the sine, the cosine, and the tangent from angle S. Then we're also going to try to find the sine, the cosine, and the tangent from angle R. So, again, I went ahead and just drew out my triangle. And I'm going to start with the sine of S. So I'm going to go ahead and start with my angle S. And I went ahead and boxed it for you, okay? So again, the opposite side of S is 5 because it's opposite. Adjacent is right next to, which is angle 12. And then your hypotenuse is side 13. So my sine of S, and so again, we want to think SOHCAHTOA. So SO is opposite over hypotenuse. So the opposite of angle S is 5. The hypotenuse is 13. So we're going to have 5 over 13. Now we're going to look at our cosine. Our cosine is CA, which is adjacent over our hypotenuse. So again, we're still starting at angle S, and so adjacent is 12. Our hypotenuse is 13. So we're going to have the cosine of S is 12 over 13. And then last, we're going to have the tangent. And tangent is TOA, which is opposite over adjacent. So we're still starting at angle S, and we have opposite over adjacent. So our opposite side is 5, our adjacent side is 12. So we're going to have the tangent of angle S is 5 over 12. The second one we're going to look at is our angle R, and I went ahead and circled that one for you. So again, we want to find the sine, the cosine, and the tangent. So the sine is SO, which is opposite over the hypotenuse. So the opposite side of angle R is 12, and our hypotenuse is 13. So the sine of R is 12 over 13. And then our cosine is CA, which is adjacent over hypotenuse. So angle R, or side R, I'm sorry, angle R, the side that's adjacent is 5, and then our hypotenuse is 13, so 5 over 13. And then last is our tangent of R, and tangent is TOA, which is opposite over adjacent. So the opposite side of angle R is 12, and the adjacent side is 5. So we have 12 over 5. Okay? All right. Now let's go down to trigonometric ratios. Now, if we know that this angle is 25 and we know that this angle is 90, we need to find what is our third angle. So we can find our third angle by setting up, we know that all three angles in a triangle have to be equal to 180. So I went ahead and I added the angles they give us, which was 25 and angle 90. So over here you see I put 90 plus 25 is 115. And then I subtracted 115 from 180, which gave me 65. So I know my third angle has to be 65 degrees. Now, we need to find what is the sine of 25 degrees because it's asking us to find side A and B. So let's go back to the notes. It's asking us to solve for side A and side B, but we really only know the hypotenuse. So what you're going to do is you're going to look at, they gave us 25 degrees. Now, we can do with sine, which is opposite, which is going to be B, over our hypotenuse. So I put sine of 25 degrees is 0.4226. Now you need to find that out with a calculator. So I'm going to go ahead, I'm going to go to scientific calculator. I'm going to show you how we can do that, how we can find the sine. So sometimes it'll be given to you, and sometimes you'll actually have to use it with a calculator, okay? So I'm going to go ahead and I'm just going to give it to you. So the sine of 25 degrees is 0.4226. So what you're going to do is you're going to set up the ratio. So 0.4226 is the sine of 25 degrees. And that's going to equal opposite over the hypotenuse, which is B divided by 8. Now, you got to get B by itself, so you multiply by 8. What you do to one side, you have to do to the other side. So we can get rid of our 8's here. And 8 times 0.4226. So I went ahead over here and I did the math. So 0.4226 multiplied by 8. 8 times 6 is 48. 8 times 2 is 16 plus 4 is 20. 8 times 2 is 16 plus 2 is 18. And then 8 times 4 is 32 plus 1 is 33. We're going to go ahead, we're going to move the decimal 4 times, which I did. And that gives us 3.3808. And that gives us what side B is. And last we need to find, what is side A? Now we know what 65 degree is. We know that the third angle is 65 degrees. So let's use that angle. And again, you're going to go A over 8. And for 65 degrees, that's going to be opposite over the hypotenuse. So it's going to be the sine of 65 degrees is A over 8. So I went ahead and I gave you what the sine of 65 degrees is, and that's 0.9063. So I set it up. I said 0.9063 is equal to opposite over the hypotenuse. So the opposite is A divided by 8. Now I got to get rid of 8 to make A by itself. So I multiply 8 by both sides. I get rid of my 8. 8 times 0.9063. I went ahead and did the math over here. So 8 times 3 is 24. 8 times 6 is 48, plus 2 is 50. 8 times 0 is 0, plus 5 is 5, and then 8 times 9 is 72. And you move the decimal over 4 times, and you get 7.2504. So side B is 3.3808, and side A is 7.2504. Now let's look at example 6. Example 6, let's go to our notes. Now example 6 gave us 37 degrees. And again, it also gave us 90 degrees. So to find the third side, all three angles in a triangle are equal to 180 degrees. So you're going to add 90 and 37, and you're going to subtract it from 180 degrees to get your third angle. So go ahead and do that, and go ahead and do this one on your own.